Soap making is ancient and may have been discovered by people as early as cavemen, when fat from cooking meat dripped into hot fire ashes and produced a slippery residue that removed dirt and grime from skin when mixed with water. Potash or lye is a strong alkaline residue produced from ashes after burning wood. Originally, soaps were produced by boiling potash with animal fat such as lard. The alkaline potash contains potassium and reacts with the fatty acids of the lard to produce soap. Soaps, including insecticidal soaps, are sodium or potassium salts of fatty acids. An example of a soap is the potassium salt of oleic acid. When placed in water, the positive potassium atom is surrounded by water molecules and ionized away from the negative carboxyl group at the end of the carbon chain. The carboxyl group of oleic acid has a negative charge and is attractive to water. The carboxyl group is hydrophilic. The long carbon chain of oleic acid is not attracted to water and is hydrophobic. This prevents oleic acid molecules from becoming truly dissolved. Instead of dissolving into water, ionized oleic acid molecules organize into tiny soap droplets called micelles. As micelles, ionized fatty acids mix with water but are not truly dissolved as individual molecules. In micelles, the hydrophobic carbon chains orient inward toward each other, and the hydrophilic negative carboxyl groups face outward into the water. In this way, the micelle has a hydrophobic core that repels water and an outer electrically charged surface that attracts water. The electrical charges on the surface of the micelles disperse the tiny micelles in the water as if they were truly in solution. Hydrophobic lipid molecules such as those of grease, oils, fats, and waxes can be drawn into the hydrophobic core of the micelle. The hydrophilic carboxyl groups on the micelle surface keep the micelle suspended in the water along with any absorbed lipids. In this way, soap micelles hold molecules of grease, oil, wax, and fat in water as if the lipids were dissolved. When soap micelles absorb and suspend lipid molecules such as oils and fats in water, we call this emulsification. To illustrate how soaps disperse lipid molecules, we will show soap micelles emulsifying an oil droplet. A drop of oil falls into the water and spreads over the surface. Since the oil contains complex nonpolar organic molecules, they are hydrophobic and do not mix with the polar molecules of water. Because they are less dense in the water, they lay on its surface. The soap micelles begin to absorb the organic molecules of the oil into their inner nonpolar regions. Eventually, the oil droplet is totally emulsified by the soap and held in suspension in the water, just like the micelles, as if it were truly dissolved. Natural waxes are a complex mixture of fatty acids and fatty alcohols with long carbon chains. Let us see how the wax molecules in the wax layer of insect epicuticle protect the insect against water loss. Then we will explain how dusts and soaps act as insecticides by destroying the epicuticular wax layer of soft-bodied insects to cause dehydration.